Okay, we'll try piecewise defined functions again. I got near the end of it and all of a sudden the tablet restarted, I guess. I don't know what happened exactly. Now, I particularly want to point this out because of your example 3 on page 21. And there they say a function defined by more than one equation. A function defined by more, terrible writing there, sorry, more than one equation. And the worst part about writing this is that I immediately want to go There's supposed to be death sounds or something there. We don't define a function by an equation in the sense that they seem to be talking about. So I can define a function by an equation, so implicitly define y as a function of x, then I might have something like x plus y equals 5, and that implicitly defines y as a function of x. And I could write, and you could say, well, it's not implicit, it's very explicit if I write y equals 5 minus x, and that's an equation and so forth. Yeah, I would still, though, say there's an equation, and if you want to think of a function, then that's a different thing, and because you say, well, y is a function of x here, but I could turn around and say x is a function of y there, and it is. X is still implicitly defined as a function of y. So this idea of mixing the language of equation and function definition, whoops, not sure, oh, I think I just added another page, so here, we'll go back. So, that they are different things. And, if you're defining a function, that's one thing. If you're writing an equation, that's something else. And that's one thing we want to work on in this class, is just using the proper vocabulary, because the proper vocabulary helps us to better understand what's going on. So, this is about piecewise defined functions, but let's just start, ooh, that almost came out funny. Let's start with the function definition. And, so if I want to define a function, I might say something like f of x equals, and let's use this up here, 5 minus x. Well, I'm reading some different things here, okay? There's one thing I'm reading. Here's 2, and I'll probably kind of call it 2a and b. This part is number 3, and this part is 4. Okay, so what's going on here? Well, 1, I name the function I am defining. Okay, so that's what I do first. Then second, now the reason I have an A and a B is kind of A. The parentheses say, the argument okay, the argument of the function, okay, the argument, or you all might call it the input, All right, I might call it the input. The argument or input is in here. Okay, so, and then B, the X part is the argument or input. Then 3, we had the equal sign. So let me put F up there, F, name the function, then the parentheses and the X, and then the equal sign is assign the following rule to, the function, and then as you look over there, well, in this case it's f of x. If it had been named something different or had a different argument, I'd have put that there, but it was f of x. So that equal sign is not equals in the usual sense. It's saying assign the following rule to the function f of x that we've named and given the argument. And finally 4, the 5 minus x, is, this is what is done with the argument or input. So this is what's done with that argument or input, and so that's what's involved in defining a function. So that's a function definition. Then evaluation comes after definition. Okay, and so evaluation would be something like, I'd say f of 3. Well, okay, f of 3, that's an evaluation because I want to know what happens to that argument when I put it in here, and okay, I'll get a 2 as my output. Further, I could have f of a. Well, see, I defined what you do, so even though this looks like a definition, really it's an evaluation because I've already defined what the rule is. It's 5 minus the argument. And so now my argument just happens to be this unknown a. I don't know what it is, but I put it in there, or for that matter, I could do something like f of x plus h, 5 minus x plus h. Okay, those are all evaluations, and this is the idea of function definition. Now we'll go to piecewise defined functions after I take a quick pause here to go check on my grandson. Okay, I'm back. So it's moving again now. Piecewise defined function, all that is it says, okay, I'm going to take f of x, and depending on what that argument is, I might have different rules. And so, I simply, maybe I want to use x squared when x is negative, but then I want to use the square root of x when x is non-negative, greater than or equal to 0. And so there's my definition, and here's my rule. It's just we add in this other part of, well, I have different rules depending on what my input happened to be. But I want to think of it all as one overarching rule. And that's not new to us. I mean, that, it's like sorting things or something like that. Is you do one thing if your input looks one way, do something else otherwise, and we can have as many of these pieces as we want. But that's all a piecewise function is. And see, if you realize how the definitions work and what you're reading when you see this f of x equals and so forth, I don't think it's a big stretch to have this idea of, look at my argument, where is it? Is it in here, in here? Now, it could be that I could have something like this, where f of x equals, x plus 3, as long as x is between 0 and 5. And then it could be, x squared again. If x is from 5 to 8. And then I could actually skip. Now this is strictly less than 8. Well, we'll make it less than or equal to 8. And then we'll use, something like x over 3 when x is greater than or equal to 10. And, so here, if x is negative, it's undefined. I mean, I've got nothing here. So, I can do that evaluation part, f of like -1, undefined, f of maybe 7, right, is 49, because I need to square it, 7's in there, and so forth. But, if I had f of 9, that's also undefined. Okay, because 9 isn't in there anywhere, or 8.1 isn't in there anywhere. Now, the important thing with piecewise defined functions is, notice this goes up to 5, that is at 5, but only one of them is a strict inequality, and the other has equality. So, well, they both could be strict inequalities, but only one can have equality, because it's a function, and I can't have that possibility of having two different answers for the same input. And so here, if I were to put in 5 here, I'd get 8. Putting in 5 here like I'm supposed to, I get 25. Well, 8 and 25 are not the same number. That would be very bad if I had an equal sign along with that less than. So, with the piecewise defined functions, that's all that's going on. It's not a big deal as long as you understand what you're doing with function definition to begin with. And so make sure you get that, back here with this idea of function definition, what you're looking at when you look at something like this, all these pieces to it, and then, that these all are evaluations. But I wouldn't call this equations, right? These are function definitions and then evaluations. I'm not writing equations. I'm doing something with functions, which is different. And so then, if I get that, then going to this idea of scrolled way down. Going to this idea of a piecewise function, not a big deal. Now, let me go ahead and just add one more thing. We'll put it up at the top, but you don't care. It's in a video. I mean, is the absolute value function. That's actually a piecewise function, okay? Because it matters what x is. So actually, to write this as a piecewise function, we would write minus x when x is less than 0, and we would write x when x is greater than or equal to 0. And now let's look at that evaluation, right? If I take f of negative 3, which, you know, that's the absolute value of 3, and I think everybody would tell me that's the answer 3. But look at our definition here, is that I would take the negative of x, but x is negative 3, a negative and a negative make a positive, so I get 3 just like I'm supposed to. And if I were to take f of 3, the positive 3, the absolute value of 3, according to my piecewise definition here, I would just use x, which is 3, and I get the right answer, 3. So, you know, actually, the absolute value of x is a piecewise defined function. And part of the reason we care in this class about piecewise defined functions is usually within the middle, so to speak, of any functions, where, you know, like here, if I looked at x equal negative 3, you know, kind of thing, the function behaves very nicely and calculus does well with it and everything's wonderful. We get a big happy face. Okay, there's my happy face. And but when we're at places where things change, like at 0 here, it goes from the one definition up here to this, well, this two parts of this definition goes from one part to the other part at 0. That tends to be a problem for calculus, and so that's what we'll see is that the part of the reason we want to think about piecewise defined functions is where things change all of a sudden, you know, where I have to think about various rules changing, it matters. And so even on something that's not a piecewise defined function, but if you take something like the square root of x, where this is only defined for x greater than or equal to 0, then again at 0 we can have a problem with calculus, even though the function is defined at 0. When we look at our calculus, we can find that we run into some issues there at 0, okay, because things are changing. So that's the, you know, with these piecewise functions, and of course absolute value of things comes up a lot, and so we'll have to worry about that. But again, you know that idea of the definition of a function, how it works, and then once you get that, once you've internalized that, then looking at a piecewise function is just not that big a deal. Okay, I think that's good for that, and it looks like we made it through this video.